Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is control of residual solvents as per CPMP ICH 283/95 and CVMP VICH 502/99 Annexer 1 and 2. In this video, let us learn the strategy on screening the residual solvents for pharmaceuticals. There are different strategies for screening class 1, class 2 and class 3 solvents. USP chapter 467 on residual solvents provides various analytical methods suitable for each type of residual solvents. The individual list for each class is also provided in the chapter. The residual solvents are also referred as organic volatile impurities or shortly as OVI. ICHQ3C also will provide adequate information on handling of residual solvents. Let us see some details on residual solvent. During manufacturing of API or its intermediates, many organic solvents are used as vehicles in the process. For carrying out chemical reactions, several solvents are used in the process of API or intermediates. The selection of solvents mostly depends on the temperature at which the reaction takes place. Also, solubilities of reactants play important role in selection of solvent in the process. Without using solvents, it is not possible to carry out the reactions. After the usage, the solvents are required by various methods including distillation, filtration, etc. When once the required chemical reaction is done, the excess solvent will be recovered from the process by any of the suitable methods. Significant amounts of used solvents will be recovered, but it is not practically possible to remove the entire traces of solvents from the isolated product. It is not economical to drive out residual solvents completely. Also, it is not necessary to do so. So, some amount of traces of solvents will be retained in the isolated product. These remnants are considered as residual solvents or OVI. Since these are residues, so the name. The residual solvents will be in ppm levels. Mostly the residual solvents are in parts per million range. Acceptance criteria also will be assigned in parts per million range. Let us see how control of residual solvents is done. It is the responsibility of the manufacturer to list out all the potential solvents that could remain in traces from all stages of manufacture. Information on residual solvents only in final API stage is not enough. It is required to list out all the solvents that are used in the entire process at various stages of intermediates. If the intermediate is outsourced, it is the responsibility of the manufacturer of API to provide information on the solvents that were used in that particular intermediate that was used in the manufacture of another intermediate or API process. The solvents must be classified and listed as per its class, that is class 1, class 2 and class 3. For classification in different 3 classes, you may refer ICHQ3C or USP 467 chapter. If there is any solvent that is not listed in official classification, it is the responsibility of the manufacturer to establish the acceptance criteria based on several studies including toxicological study. This is important. It is necessary to evaluate the toxicity of the solvent that is not listed in the defined classes. Acceptance criteria should be based on all these factors. The residual solvents must be evaluated as prescribed under USP 467 chapter. As said in the previous slide, you have to use this chapter for evaluation. Let us see the strategy of control. Because of their serious toxic nature, class 1 solvents such as benzene, 1,2-dichloroethane usage should be avoided in manufacturing of API or intermediates. Class 1 solvents are very toxic even at very low levels. Removal of impurities to acceptance limits is also challenging. So, to the extent possible, it is recommended to avoid the use of class 1 solvents in the manufacturing process of API or intermediate. If used in the manufacturing process under unavoidable conditions, with adequate scientific justification and supportive evidences, the traces of class 1 solvents should be monitored at suitable intermediate stage or in final API product. Wherever it is necessary, the use and monitoring the residual solvents should be detailed with justification. The remnants may be screened in the final product or at any suitable intermediate stage. Class 1 solvents may appear as byproduct from a chemical reaction or may arise from another solvent like toluene or acetone containing benzene. In such cases, also it is necessary to monitor the class 1 solvent presence. Many processes use toluene and acetone as protein solvents in the process. It is necessary to screen for all potential residual solvents present in the final product as a part of release specifications. Routine screening for class 1 solvent may be not required when limit applied by the original manufacturer of solvent is below the maximum limit of solvent possibly present in the final product. The first condition is that the original manufacturer should list in solvent specifications with the content of class 1 solvent. The limit should be such that the level of class 1 solvent present in the final product where it is used will be within the specified limit. For example, if toluene in the final product is within 890 ppm as prescribed in ICH Q3C, toluene used in the process should contain less than 2 ppm benzene in that amount of 890 ppm. You can calculate the benzene content in the solvent to meet this specification. Generally, benzene content in toluene is controlled at around 300 ppm. This value will give comfortably below the maximum limit of not more than 2 ppm in the final product. If it is established that the level is not more than 30% of the limit specified in the final product from 6 consecutive pilot scale batches or from 3 commercial industrial scale batches from a suitable intermediate or on the final product. This is important. If the value is less than 30% of limit in any suitable previous step, intermediate or API, the screening in the final product can be skipped. If it is benzene, 30% of the limit 2 ppm, that is about 0.6 ppm. If the value is less than 0.6 ppm, the screening in final product can be skipped. Same reasoning is valid for all other class 1 solvents. If the original manufacturer of solvent screens routinely the class 1 solvent for compliance to acceptance criteria, This is also acceptable. The original manufacturer should declare the content of class 1 solvent so that the value is suitable to get the class 1 solvent within the limit. Class 2 solvents, when used, should normally be controlled either in a suitable intermediate or final product. Let us see the requirements for class 2 solvents. Class 2 solvents can be monitored at suitable intermediate as like in class 1 cases. Class 2 solvent traces should be monitored as per the limits prescribed in ICH Q3C guide. This list is also available in USP 467 chapter. If it is established that the level is not more than 10% of the limit specified in the final product from 6 consecutive pilot batches or from 3 commercial industrial scale batches from a suitable intermediate or on the final product. Just as in the case of class 1, the screening can be carried out at a suitable intermediate, but the condition is that the level should be within 10% of the specified limit. For example, the results should be within 89 ppm for toluene, 42 ppm for acetonitrile, and 300 ppm for methanol, etc. Let us see the strategy for changes, if any, to the process. The manufacturer should evaluate the impact of presence of class 1 and class 2 solvents when there is a change to the process. This step is important. It is necessary to carry out risk assessment for any change to check if the existing limits are still relevant. The impact analysis should include even if the levels of class 1 and class 2 solvents are below the threshold limits in the initial validation to check whether or not same validity holds good after the process change. Let us focus on residual solvents in dosage forms. Use of class 1 solvent for manufacture of dosage forms is not acceptable. In processing of dosage forms like tablets, capsules, class 1 solvents should never be used. The dosage form specification should include screening of organic solvents in the finished product. So the dosage forms should be tested for residual solvents. Process validation results are not considered to adequately justify the omission of such tests from the specifications. The validation data can be used to justify skip testing. The validation data may be used to skip testing or reduce testing. Let us see how class 3 solvents are handled. Class 3 solvents are least toxic and may be used in the manufacturing process. Relatively, the toxicity of class 3 solvents is much lower than class 1 and class 2 solvents. So, less toxic, less problems in controlling the impurities. Class 3 solvents can be monitored by appropriate LOD or KF test at not more than 0.5%. Unlike class 1 and class 2 solvents, where a specific limit is assigned for each residue, class 3 solvents can be controlled at less than 0.5% as loss on time. If final isolation is only in water and there is no other organic solvent used, it can be controlled even by KF also. GC methods may also be used to screen class 3 solvents if suitable. Sometimes suitable GC method may also be established to carry out the residual solvent analysis of class 3. Analytical methods for screening residual solvents have to be validated as per USP 1225 chapter. Any testing method has to be validated if it is not a compendial method. You have to validate as per USP 1225 or ICH Q2 or even as mentioned in ICH Q14. Depending upon the routine results obtained, let us see how tightening of specifications is done. If by process efficiency the class 2 residual solvents are controlled much below the ICH specified limits, it may be tightened to not less than 50% of ICH limit, not necessarily closer to the values obtained routinely. Sometimes the actual values may be much lower. This is very important point to note. If the levels of class 2 solvents are much below the ICH limits, it is not necessary to tighten the limits to the value closer to the routinely obtained values. It can be revised to 50% of the ICH limit. For example, in a process, the methanol content in final product is in the range of 100 to 200 ppm against a specification of not more than 3000 ppm. You need not tighten the specifications closer to this range. It can be tightened up to 50%, that is 1500 ppm. Class 3 solvent specifications need not be tightened. The same value of not more than 0.5% may be retained always. So class 3 solvents need not be tightened even if the values are much below 0.5%. A certificate of declaration for the presence of residual solvents may be provided as in this slide. A declaration on usage of solvents may be provided for routine compliance. The format may look like: no class 1 solvents are used in the process. So and so, so and so, and so and so class 2 solvents are used and they are controlled as per ICHQ3C. Similarly, so and so, so and so, and so and so class 3 solvents are used and are monitored at not more than 0.5%. This is another important point to note. A declaration on usage and controlling of different classes of solvents can be given as in this example. If no class 1 solvent is used in the process, the declaration is accepted. It must be understood that if tested for class 1 solvents for this product, the test would pass to the requirement. Similarly, you can list out the class 2 and class 3 solvents and declare that they will be controlled within the limits as prescribed in ICH Q3C. I hope that the information on controlling of residual solvents is understood well. Read the guidelines as given in the topic title slide. You get more intricate information. Work out how this could be executed into your routine residual solvents screening system. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.